Hi, I'm Murad.
And I'm Ane. This semester, for STEM Pathways, me, Murad and Rahil worked on a seed bowl dispenser drone system. Initially, at the beginning of the semester, we decided that we want to swap away from the initial drone that we were using and make it for the DJI drones, which is a more common drone. To start off, we made a cardboard prototype, and then after that, we started to design on Fusion. Our first design featured boxes that could clip onto each side of the drone's legs and have a space for the servo motor that would fit. Here's an image. After using the design cycle, we realized that the servo motor wasn't mounted properly and wasn't able to fit in the box. The clips were also a bit too flimsy and kept on breaking when 3D printing. To solve this, we decided to use this design to mount the servo and then make the clips for the wings a bit stronger by making them a bit thicker. This is what we ended up with. Here's another image. After this, we decided we wanted to make it compatible with all DJI drones, which would mean that we needed to have it adjustable for width. We first decided to use a screw system where we would have multiple holes and then you would be able to screw which hole would fit your drone. Here's an image of us trying it. And here's of it, both of them together. After this, we realized that the holes weren't lining up properly, and the issues with the 3D printer was that it was printing too close and the holes were too small for the 3D printer to get accurate. So, instead of this, we decided to use Velcro, which was much more simpler and much easier to mount to the drone. We also realized that the servo needed a space over here to fit the wire and the cables through. So this is how we ended up with the final design, where we have Velcro mounted clips for adjustability between DJI models, as well as a servo mount here, and we will mount the electronics on this side of the box.
Also using Velcro.
And that's the design process of the box that would dispense the seed balls.
So moving on to the technical aspect, initially what we thought was that we'd hook up a motor or the motor to the DJI remote or the drone remote. Now this worked for all drones except for DJI drones that we tested. So obviously that wouldn't work. Now the reason that didn't work is because DJI, they wouldn't let us, like you can't add motors to it in an accessible way and in a compatible way for all drones. So what we then decided to move to is a cell-based system where, well, we then decided to move to a GPS-based system where the motor is connected and you put in a predefined coordinates. We put a lot of work and a lot of research and development into that system, and we ended up with something like this. Now the issue was how to program it. So then we used a Raspberry Pi. Now we are working in the future to eliminate the Arduino board fully and just use the Pi and the SIM receiver. And hopefully, instead of using network in the future and mobile hotspots, what we will move to is we will use SIM-based messaging. So you would just message the SIM card and tell it the coordinates instead of it hosting a hotspot. Another project we worked on this year with me, Rahul, and Ane was the smart walking stick.
So again, we followed the design cycle in that project, and we used a complex system which featured ultrasonic sensors, motors that would rumble, and wires that would connect them. So to test the prototype, the first one we just did it on breadboard, and we just made sure that the code and the ultrasonic sensors would work. And after that went well, we decided, here's some results. After that, we decided to also try solder it and see if it would fit on our walking stick, which is where we have this, where we soldered all the ultrasonic sensors to the Arduino Nano, and then we connected the rumble motors. Based on this, and we decided we needed clips that would sit at the bottom of the walking stick and throughout, which would keep the wires from just staying in place.
So the research and development of this project was We started with thinking that all the electronics should be on the walking stick, perhaps in the walking stick handle, and we sooner or later moved towards a more strap on the arm, which indicated the motors in which direction. So that's where we're at right now. Yeah.
Yeah, we're still working on this project and we hope to finish it soon.
Thank you very much.
Thank you.